eating carbohydrates might be the biggest dietary mistake that almost everyone is making. I know this seems controversial because if you look at any like guideline, it will tell you to eat the majority of your diet in carbs, like in grains, seeds, nuts, legumes, even like fruit and vegetables. We'll get to that in another video. But carbs actually aren't essential and might even be actively causing damage. So let me explain. Give me a few minutes and then make your own conclusion. So firstly, yeah, they're not essential because essential means they can't be synthesized by the body. So there is such a thing as essential amino acids, and if you didn't know, amino acids are what make up proteins. Like if a house is made out of bricks, proteins are made up of amino acids, and then there are essential fatty acids, which obviously you get from fat. So there are essential proteins and fatty acids that your body can't make, but there are no essential carbohydrates. There's no such thing. So we'll get back to how your body makes it in a second, but first I'm just going to talk about the Randall cycle. You may have heard about this already, I've mentioned it as well. But basically what is your body's competition for using glucose, which is sugar, as energy and fat as energy because it can't use both at the same time. And if you didn't know, when you eat carbs, it turns into glucose, it turns into sugar, and that's how your body uses energy. So it's pretty much the competition between fat and carbs. And basically it will stress your body if it's constantly trying to compete between which fuel source. Because if I eat like a modern diet which is high in carbs and high in fat, then my body will be confused trying to use both, and then it will have to put one on hold while doing the other one, so the other one just sits around there causing damage to the body. And so yeah, chronic upregulation of this competition will lead to stress, inflammation, oxidative damage, mitochondrial dysfunction, like it impacts mitochondrial function, etc. So there are like quite a few ramifications of upregulating this cycle chronically. And so yeah, something you want to avoid. So next I'm going to talk about gluconeogenesis. So what this is, just to break down what the word means, gluco meaning glucose, so sugar, neo, new, and genesis, origin or formation. So it's pretty much the idea how your liver and kidneys will produce sugar by themselves. So that's what I was saying above, how there are no essential carbohydrates your body needs because your body can produce them all endogenously in your body. So I won't go into too much detail, but basically it takes stored fat, so triglycerides, which is just stored fat, goes through this thing of lipolysis where basically it breaks these down into smaller things, including nephers and glycerol. Then the nephers will be oxidized, turning ketone bodies used for energy, and the glycerol will be go through glyconeolysis, turning into glucose. Then that glucose will then be sent to muscles, be stored as glycogen, and be used how much you need or in the amount you need, and some will be circulating in your bloodstream, maintaining that balance. So what's interesting is your blood glucose has to fall within a very specific low range, so 4 to 5.5 nanomoles per liter. And basically what this means is about 1 or 2 teaspoons in your entire body, in your entire bloodstream at any given time. This number is optimal for health. And so if you eliminate exogenous carbs, if you stop eating carbs, it eases your body's ability to maintain homeostasis. So you can maintain that exact level for much longer and much easier without stressing your body out nearly as much just by eliminating carbs from the diet. Because obviously, when you eat carbs, it will spike your blood sugar, which then causes insulin to tell cells to absorb the sugar to then transport it elsewhere. But you don't you don't trigger your insulin if you don't eat the carbs. So then there's no potential insulin resistance. And insulin resistance can cause a whole host of issues, including chronic inflammation, which is the birthplace of a lot of modern diseases, like even cancer, diabetes, cardiovascular disease, all stems from chronic inflammation. But then this study as well on insulin resistance, it says here, a lot of them can lead to vascular complications, so complications with your vessels, um, retinopathy, nephropathy, peripheral neuropathy, dementia, stroke, mood disturbance, gait instability, cardiac microvascular disease, angina, coronary artery spasm, cardiomyopathy. So all of these, you can keep reading. You can pause it, keep reading. Non-alcoholic fatty liver disease, type 2 diabetes. All of these things can stem from insulin resistance. Plus, there's also things which can stem from chronic inflammation. So super, super damaging. So now you might be thinking, like, what about energy? Because I know I talked about how you can use fat, but let me explain how that works. So when carb intake drops, your body will actually start using stored fat for energy, lipolysis, which is good if you're overweight. And if you're not, you need to make sure that you eat enough fat throughout the day so that you can replenish those triglycerides which are being broken down so you can maintain your energy. And so how ketosis happens, basically, yeah, I'll just start in the top one, I guess. So yeah, if you restrict your carbs, you'll have reduced blood glucose, like we said, and insulin. Then the fat stores will be broken down, and free fatty acids are released into the bloodstream. The fatty acids are then transported to the liver and used in the production of ketone bodies, like we saw in gluconeogenesis. And ketones basically are like, the easiest way I can put it is like the energy that your body uses that comes from fat. And so ketones are circulated throughout the body and used as an energy source by the brain, heart, and skeletal muscles, right? And there are some actual prospective benefits of using ketones as opposed to glucose as your energy source, apart from not spiking your blood sugar. Um, these are various prospective benefits, including neuroprotection, so protection of your nerves, less stress on your mitochondria per energy unit, protection and prevent cell death, antioxidant gene activation, anti-aging potential, optimize electron transport, and efficient ATP production. For example, like every 1 calorie, which doesn't exist, I made a video on it, of fat produces more actual energy, ATP cellular energy, than 1 calorie of carbs. So you need to eat fewer calories of fat to get the same energy production. And there was even this study here in the American Journal of Physiology, Endocrinology, and Metabolism 2020. And so one group was a habitual diet, so you can see fat, protein, and carbs like this, and the other was a ketogenic diet, so eat majority fat. And the ketogenic versus habitual diet had all of these benefits. So HOMA-IR is homeostatic model assessment for insulin resistance. So basically they had lower insulin resistance. The ketogenic diet, people who ate low, so even though they ate more fat, less insulin resistance, they had less fat stored in their body despite eating more fat. It's weird how that works, but it just is. They oxidized fat quicker. They had more muscle glycogens. They had more like energy in their muscles, more muscle triglycerides, more ATP production from fats. They could actually, your body became more efficient at converting fat into energy, and more ATP relative to hydrogen peroxide. Hydrogen peroxide is quite stressful in the body, so having more ATP relative to that is a positive. And yeah, from personal experience, this ATP efficiency is very true, because when I started the keto diet, I was having like crazy, or like the carnivore diet, I had crazy cravings for carbs. Like in the night, I just start like eating chocolate, and it was like a stupid idea, and I shouldn't have done it, but I was just like so craving, or like I was eating like spoonfuls of honey. But within, I don't know, 3-4 weeks, I pretty much just, the cravings all stopped and my body just fixed itself, and now I'm fine. So there is like an adjustment phase, which makes sense because you're not used to it. So there are some counter arguments, which is if you're a high intensity athlete, which I don't recommend this lifestyle because obviously it's super stressful. But if you're adamant on like competing in a sport or like doing high intensity, then you probably should consume carbohydrates because it'll probably be less stressful on your body than exercising and trying to use fat for it. And some people have a poor adaptation to ketosis genetically, so there might be some points for that. But yeah, that's it. I hope I convinced you. I think it's pretty convincing. It's convincing enough for me. And yeah, I appreciate you watching. If you're still here, let me know what I should talk about next, and I'll catch you in the next one. See ya.